In today's lesson, we're going to learn about squares, square roots, and perfect squares. And some of these may be review for some of you. All right, so first we have this information in the box. So we need to know when we're talking about a square in terms of numbers, what are we referring to? So a square is the product of a number and itself. For example, 36 would be a square because it is the product of 6 times 6, okay? And as you'll recall, when we read this as 6 squared, okay? So that's where that comes from. 36 is the square of 6. All right, the next part talks about square root. And so the square root is one of two equal factors of a number. For example, the square root of 9 is 3 because 3 times 3 is 9. So this, when you see this symbol right here, this is telling you, saying what is the square root of 9? Meaning what number times itself is equal to 9? And they're telling us 3 because 3 times 3 is 9. I want you to add over here on the side, negative 3 times negative 3 is also equal to 9. So the square root of 9 is 3 and negative 3. There are two square roots of every number. There's the positive square root, which this one referred to, and the negative square root. Okay, so let's just add that information in. The next part talks about the radical sign. You might have referred to that before as the square root symbol or the square root sign. Okay, and then there's something called a perfect square. And a perfect square is a number whose square root is a whole number. So you can take the square root of any number at all, period. And you've probably seen that square root or radical sign on your calculator before. If not, pause the video right now and go look for it. So a perfect square, in this case, the example says that 16 is a perfect square because when I take its square root, I get the whole number 4. For example, 24, not a square root. There's not a whole number multiplied by itself that would give me a value of 24, okay? So let's go look down here. So perfect squares. So we have 3 examples here, right? 2 times 2 is 4, 3 times 3 is 9, and 4 times 4 is 16. So are the shaded portions squares? Yes, each of those shaded portions are squares. And how do we know? Well, when you draw a square, the length and the width are the same. So they are squares because this one is a 2 by 2, that one's 3 by 3, and this one is 4 by 4. So they are squares because let's say the sides are the same length. And you probably learned how to identify squares or learned that squares are their sides all have the same length probably back in 2nd grade. So, or maybe before then. So that's not new information, okay? So here, these are all examples of perfect squares. 4 is a perfect square because 2 times 2 equals 4. 9 is a perfect square because 3 times 3 is 9. And then 16 is a perfect square because 4 times 4 is 16. Okay, so those are all examples of perfect squares. 4, 9, and 16 are just a few. All right, so then it says, using this grid, color a perfect square larger than 16. And then tell me why is you're drawing a perfect square. So I want you right now to pause the video and do those 2 things that I put the little asterisk at. So make a perfect square larger than 16 and tell me why it's a perfect square. So pause the video now. Okay guys, so this is the perfect square that I drew. I made a 5 by 5. So 25 is the perfect square because I can make a square using 25 little squares, and their side lengths are all going to be the side lengths would be the same. In this case, 5 by 5. You may have made a 6 by 6, a 7 by 7, an 8 by 8. So long as your side lengths are the same, then you have made a perfect square larger than 16. So as long as it's larger than a 4 by 4, okay? So this is a list of perfect squares. Not the 1, the 2, the 3, the 4, the 5, but what is 1 squared? Remember that 1 squared means 1 times 1. I'm going to use the dot for multiplication. So 1 is a perfect square. 2 means 2 times 2, which is 4. So 4 is a perfect square, okay? So I want you to go ahead and I want you to finish filling out the perfect squares. So go ahead and pause the video and finish filling this out, and then we'll check back. Okay guys, so pause the video and check over your answers for these perfect squares. Great. So remember that the numbers that are highlighted, those are the perfect squares. 1, 4, 9, 16, 25, 36, 49, so on. Those are the perfect squares, not 8, 7, 6. So the highlighted numbers, your answers, are the ones that are the perfect squares here. Okay, so let's go to the next page. Now we're talking about square roots. So square roots are the blank of perfect squares. So square roots are the opposite or inverse. We'll say opposite. A square root of a number is one of its 2 equal factors. So remember that factors are numbers that you're multiplying together to get a product. So for example, in the next bullet point, 4 times 4 is 16. 4 and the other 4 are both factors of 16. So 4 is the factor of 16, and it's also, in this case, well actually let's not put factor there, let's put square root there. The 4 would be the square root of 16 because both of those 4's are factors. Let's write it right there. So the 4's are factors, and it's the same factor being multiplied by itself to get 16. So we can write this, as you see here with that radical symbol. The square root of 16 is 4. The square root symbol are called a radicand or radical symbol is used to show a number's square roots. So here are some examples. The square root of 4 is 2 because 2 times 2 equals 4. I also want you to put under here, so you need to zoom in. Negative 2 times negative 2 is also equal to 4. So let's change this to that plus or minus. The square root of 4 is either positive or negative 2. There are 2 square roots of every number. So when they say the square root of 9 is 3, it's plus and minus 3, meaning the positive 3 and negative 3. Same thing for 16, all of these. So add that plus or minus there. So the square root of 9 is positive 3 and negative 3 because we can do 3 times 3 and get 9. We can also do negative 3 times negative 3. We can do the square root of 16 is 4 or negative 4 because 4 times 4 is 16, and so is negative 4 times negative 4. The square root of 25 is 5. You're getting the pattern here because 5 times 5 is 25. Also add in there that negative 5 times negative 5 is 25. And then the square root of 100 is positive 10 and negative 10 because 10 times 10 is 100 and negative 10 times negative 10 is also 100. Now, an important thing to note, if I were to type into my calculator the square root of 4, it's only going to give me 2. It's not going to say negative 2. So when you're asking the calculator to give you the square root of a number, it only gives you the positive square root. But there are technically 2 roots, okay, 2 square roots of every number, the positive square root and the negative square root. So we need to keep that in mind. All right, so what I want you to do right now is I want you to do this bottom section. So I'm just going to circle right there. Complete these problems. This is to find each square root. In other words, what number times itself gives you 81. That's the first one, okay? And I want the positive and negative square roots of each number. So pause the video and do that now. Okay, so notice, everybody, that my answers, like I put plus minus 9. That's a shorthanded way of saying positive 9 and negative 9. Instead of me writing the 9s twice, I can write it once with that plus minus, and it means positive and negative. So if you didn't notice, you could have looked back at this page where we listed the perfect squares to help you get those answers really quickly. Okay, so now we're going to go to this last page. And for this last page, I'm going to have you go ahead and do this entire page right now. So go ahead, try each of these problems on your own, and we'll come back and check. Good luck. Okay, everybody, so we're going to check over our answers, and you may need to pause the video in order to get them. So here you can see 1 through 15. Okay, I'm going to slide it up. And then let's see. Okay, and then you should be able to see the rest of the problems now. Okay, so if you have questions about anything we've done in today's lesson, please bring them to my attention so that I can assist you. After you turn this in, you're ready to work on your independent practice. Good luck.